What's the basic function? Square root of x. And if I go in, I start with the inside, and the inside is 1/2 times x. So that says I have a what?
Stretch.
Yeah, because c is 1/2, and 1 over c is 2. So that says I have a horizontal. I put h in front of it because I don't want to write the word horizontal. And 2 is a stretch factor of 2. And that means to perform this guy, I'm going to take 2 and multiply it times the x values. And that makes sense. What it does is it makes the x values bigger. And if you make the x values bigger, then that means the graph is getting wider. Because I know it's going to be a horizontal stretch. Horizontal stretches go this way. It won't be too long till I'll have you making designs in the air. Yes?
What does it say at the top corner?
C is equal to 1/2,
Oh, okay.
so the 1 over c is 2. So now I need to set up my table. So this is the square root of x. And 0, 1, 1.4, 1.72. You get so used to that. And that says I'm just going to take 2 times the x values, which is 0, 2, 4, 6, 8. I had to think about that for a second. That's my new graph. Now let's think about what happens whenever I take square root. And square root looks, let me get my paper. Here's basic square root. If I'm going to stretch him, I'm going to grab him right here and pull him like taffy. So if I'm going to grab his arm and pull him, what's going to happen? He's going to begin to flatten out.
Yeah, he'll get closer to the x.
Yeah, he gets closer to the x-axis when you stretch him out. Why? Because this guy's tacked down. So it's like, okay, you're going to pull him, that's tacked down. There's no place for him to go except down. So that widens him out. So that if I look at the new one, I have 0, 0. I have 2, 1. I have 4, 1.4. I have 6. I'm now off my graph paper. 6, 1.7. That's the best I'm going to do. And he keeps going like that. Now, what does the basic one look like? So this is a graph of f of x equals 1/2, or the square root of 1/2 times x. Square root of x, 0, 0, 1, 1, 2, 1.4, 3, 1.7, 4, 2, and if you look at the, and this is y equals the square root of x, that's your basic. Has he indeed flattened out? Mm-hmm. Yeah. The thing you have to understand about math people and people who go into the science areas, you learn to think in pictures. So many times when I am teaching you about something, I have a picture in my head and I'm describing to you what's going on in the picture. So when I visualize stretching, I literally do visualize this thing and then grabbing a hold of him and pulling him. What's going to happen to him? Well, there's no place to go, but he has to go down. Now, if I look at 4 square roots of x, what do I notice? I notice it's a 4 times x. So in this instance, c is 4, and 1 over c is 1 over 4. So if that's the case, what do I have? A horizontal shrink. See, once I know what the number is, I know whether it's a stretch or shrink. That says my x values are going to be 1/4 smaller. That's going to bring it in this way. So it crunches it. Instead of making the x values bigger, I'm making the x values smaller. So it compresses the graph. So our basic function, of course, is square root of x. And as I write what the transformation is, it's a horizontal shrink factor of 1/4. That's my multiplier. And by the way, if you're actually going to just list the transformation, you could just say horizontal shrink and don't worry about the factor. If you're graphing, I worry about the factor because that tells me what my multiplier is. I'm going to be multiplying by 1/4. So what am I going to do? I'm going to take 1/4 and multiply it times all the x values. And what that should do is that here's the tack. It should push that graph in. But as I try to push it in, it's probably going to do what? Rise up. Because I'm operating off a fixed point. So here we go. The basic is square root of x. So it's 0, 1, 1.4, 1.7, and 2. You probably have these numbers down by now. And I'm going to be on the x side. So I'm going to multiply by 1/4. So it's 0, 1/4, 1/2, 3/4, and 1. Notice that this guy used to go between 0 and 4. Now this graph piece that I have is going between 0 and 1. Crunch. Is he going to be hard to graph? This is him. He's gone from here, whoops, sorry, between these two. Now that whole graph is here. The whole thing. So is he going to be difficult to graph unless I scale the paper? Yeah. So I'm going to scale the paper. So this is 1/4, 1/2, 3/4, and 1. So I can get a picture of him. Because otherwise I won't have a picture. So it's going to be 0, 0. 1/4, 1, 1/2, 1.4, 3/4, 1.7, and 1 is 2. And he's going to look a lot like the basic. And this is essentially f of x equals the square root of 4x. That's your transformation. Now, if I were to try to graph the basic on top of it, yeah, I'd have 0, 0, and then 1, 1. And that's the only 2 dots I could get there. That's your basic. And notice the new graph is, because what? You pushed him in. He has nowhere to go but up. Because he tacked down there. So the more you push, the more he rises.
Can you scoot over just a little?
Which direction? So that's what I would expect.